Good morning, everyone. Доброго ранку. Hyvää huomenta. Long time no see. Let me know if you can see me well and hear me well. Meanwhile, I'm gonna start my first stream of the year. Good morning, everyone. Good morning. Hey, all the friends are here. Well, I presume. The setup is a bit changed, guys. Today is gonna be no chroma key, so gonna see some background. And mostly that's because I got the three.js thing here, so I need to show it. I need to show it to everybody. Hello to Poland. And yeah, by the way, just let me know where you're from, so we can check the geography today. I'm obviously in Kiev, Ukraine. I wasn't quite able to stream because these fuckers are attacking my country and I had too many blackouts for the past month. But now, thanks to the armed forces of the Ukraine, I am able to stream and I have power and I have internet. So let's do that. So, without further ado, let's start. I'd also like to thank everybody who supported me on Patreon during this period, because I obviously couldn't stream, but a lot of people still supported me and I'm very thankful for you guys. Thanks a lot. And also to Ryan from New Jersey, who left a really wholesome comment that touched me, and I decided I have to stream now. There's no other stuff, because I'm still a bit sick, but that's not gonna stop me. Anyway, so let's get started. Enough of my face on this whole screen. Let's see something real beautiful. So today I wanted to show you a little bit of how the midwam.com is created, how they create this look. Of course, not the whole website, obviously, but just a part of it. So credits go to the Immersive Garden Studio, one of the best studios, obviously. Like, there are a lot of like flagship studios out there with the webgl effects. This is just one of them. I mean, not just, it's one of the best ones. And they created this amazing experience. And today we're gonna try to create something like it. Try to see how looks like that are created and how you can achieve this thing. Hello to everybody. Hello to Texas, Poltava, Netherlands, Turkey, Australia, Georgia. Whoa. So we pretty much have, again, the whole planet. I mean, probably. Oh, thank you. I'm flattered. So yeah, let's get started, right? I'm gonna call this folder midwam. And I'm gonna start with my usual template. You can find it on Patreon. I also coded it in some of the other streams live, so I'm gonna start it. Yay. So what's that gonna be? Okay, the code's gonna be on the left. So you don't get distracted with my beautiful face, the right bottom corner. Yeah, like this. And then it's been such a long time. I think I'm starting to forget, like, how do you even run this thing? How did I even stream so many times? I think it's over 150 streams now. And yet 2 months of the pause in the streams, and then it's hard again. Yeah, all their websites hit the work of art. That's true. That's one of the best studios. Will I build Chrome extension? I don't know where this is coming from, but not in this stream. I had another stream where I've actually built a Chrome extension for the frame per second counter, but not today. Morning and Happy New Year and Happy Holidays to everybody. We actually had a Christmas just yesterday, right? I mean, second Christmas, which is probably not gonna have it next year, I guess. anymore. We're gonna have the Christmas as everybody in the world have it. Okay. Okay, there's a mid1com that's running the template. Let me check if I don't, because I don't have a chroma key and I'm afraid I'm gonna hide something important behind my video now. Might as well just hide it, but yeah. Then you wouldn't be able to see the three.js, where is it? Here, three.js neon lights. Okay, so we have this, we have this, we have mid1comp. We are ready to start. Hello to Lithuania. Right. So this is a really beautiful website. And yeah, just let me... Oh, thank you. Yeah, maybe in the end of the stream I'll show some of the stuff that I've been like creating lately, because I don't really post it to Twitter, mostly to the Instagram. And then again, 90% of the stuff I don't even post anywhere because I don't think it's good enough. Anyway, here's a template. Here's what we render so far. So let's start creating mid1com look. Obviously, we need a model. This is not a model generated with some procedural JavaScript or GLSL. This is obviously a model. So let's get this model. I think it should have called human or anyway. GLB, yeah, it's a human. Let's get this one. And also for this look, it will be important to get an image, but let's first start with the human GLB model. Okay, so we have the human GLB right here. I have a GLTF loader right here. So we can start by just showing the model, at least in my template. Instead of this add object stuff, I'm gonna just delete everything here. Don't really need all of this. Yeah, I actually tried to create some ray marching animation with the chat GPT, and well, I was successful. It's yeah, it's kind of like, okay, it just does that. Right, so I don't need this. Then I think I can just load my model. Get the GLTF, made the font bigger. GLTF. And then do something, but I need this model. And it's gonna be human GLB, right? But I mean, ChatGPT, of course, is amazing, but I've been kind of slowly coming to it with the Copilot, because Copilot actually kind of a similar thing, right? It just writes code for you, but it does that, right? You see what it does for me. And that's probably the right code, actually. That's probably what I need, which is so weird. Like, let's try it. Let's just go with it. Just go with the AI. Okay, I don't have the, yeah, because it's probably there. Okay, now we don't have anything. Oh yeah, because I've deleted my usual stuff. Okay, yeah, three.js actually changed this URL, and I had my old template because I haven't streamed for quite some time. And the easiest way to fix is to do this, but this should be a better way to do this. Should just change the def to some version of the... And well, yeah, it just loaded the wireframed model for me. Really, this was the AI. Like, yeah, but it didn't change it. It didn't center the geometry, actually. I would prefer something like this, but yeah, still quite good. Yeah, just so we look like kind of in the center. And then maybe the scale is not quite right. Yeah, getting better. And then also the wireframe, but well, that's useful actually to debug when you load the model first time. I don't really need this, because I think what's going to be this human? Let's see what's inside it. The human is actually a mesh, so I don't really need to traverse it, because this is already a single mesh. Right. So this is just black because, yeah, because I don't have lights, and this is probably a mesh standard material, which is always black if you don't have any lighting on your scene. It creates a really dark background, so we are not able to see anything, but you could see, right? It's 0101 and then it goes to 0. This is where the model is. Not the best way to preview the model by far, but still, we can now change the material of the model. We can do something with the material. Let's create a mesh basic so we would be able to see it. What's your favorite color? I think mine was this kind of orange. Anyway, so we have the model. Now, how do we go from this? It's like in those tutorials, right? You could see just this, and then we need to go to... Where's my beautiful mid-one? We will need to go to something like this. All right, let me just check the chat. What will happen when they will merge? Yeah, I'm actually more afraid of what will happen when the ChatGPT and Copilot got more React 3 Fiber code, and with the latest demos that React 3 Fiber is showcasing, I mean, it's crazy. We might as well be left without the jobs then. Because you're gonna just write, make me a beautiful semi-transparent object of something with the beautiful shadows, and it will just do that. And in like 60% of the cases, this is the only thing that is needed. Right, the looks of it. Now I'm gonna go into the network and look. When you debug the websites, it's always nice to look at the network, like what beautiful fonts they have here. But they should have some kind of image, right? For this light and this GLB files, even in obj file, couple of OBJ files. I'm actually curious what's inside there. I think we should have time to some small investigations right here. On the macOS, you should be able to actually preview the models. I'm not sure why I don't see anything on this desert. That might be like points or something. Anyway, let's look for the environment map. Yeah, so this is what we're gonna be using. This is the map that produces this amazing look here. But it's not that simple, you know? I mean, this image is the source, but it wouldn't be that simple, right? So this is going to be the environment map JPEG. Now, the first thing about this, why they use JPEGs? Well, there are a couple of reasons, I think. First of all, usually it's either EXR or HDR images that are used here, and you can download plenty of them, like in Polyheaven, for example. You could go and get, I don't know, there could be some weird stuff, especially in the studio. Medium contrasts. It's going to be something different. Okay. So usually those EXRs or HDRs are like 1 megabyte, and this is only 1000 by 1000 pixels, because they store 10-bit information, which is different from the usual like JPEGs or PNGs. They're not capable of storing that much of lighting information there, and that's needed so we can produce like better lighting. Those things are used as a image-based lighting, like IBL, sometimes they called, I guess. And again, this is usually HDR or EXR. This is needed for like physically correct lighting. But in this case, the JPEG is used. And usually when you do use those EXRs or HDRs, like I could actually preview our model with the different of them. I don't need to write code for that. So I could just drag the model. It's going to be right here. And then in the lighting, there's got to be the environment map. Yeah. And you could see how the environment map is changing the look of the model. So it's actually pretty important to use the correct HDR or EXR map. But again, in this case, it's a JPEG. So to use those EXRs or HDR maps, they're called they're called equirectangular, right? Because they are actually rectangular, but they are wrapped on a sphere. This is what the best example of equirectangular map everybody knows. This is the map of the world. So to use them as a real lighting, we will need to use the PM RAM generator. So the three.js has a really nice documentation on that, even with the some useful constants right there, which are actually useful. So here, I guess we will need from equirectangular, because there's as well from a cube map. We don't really have a cube map right now. We have a cube map shader compile. So we'll need to compile this shader, and then we're gonna use the from equirectangular map. So let's do that. Do we have an example of PM RAM generator somewhere? Because I have to include it from somewhere. Maybe HDR. Yeah. This is the example again with different HDRs and LDRs as well. And I believe it should be using PM RAM generator. Now we need to get it. Where do we get it? Or is it inside the three.js already? Is it included? Should I even get it? I think it's inside the three.js, so I don't even need to import it. Yeah. Ooh, it's been a long time. Yes, that's three.js. Don't know what you're talking about, but I don't really like to see this name in the chat. Okay. Uh, Where do we start? So we need to create the instance of this PM RAM generator, and I'm gonna start by creating it right here. So I'm just gonna like this PM RAM. Okay. So this is gonna be Copilot helps us again, and then compile equirectangular shader. Yeah, this is exactly what we need. So basically Copilot is writing code for me now, but no, nothing next. No, doesn't help me with the next one. No, okay. So then we need to load something. And first we need to import the being a bit chaotic here. We might as well import something with the EXR, but that doesn't really matter. So you could see that here we're gonna initiate the HDR cube texture loader, which is, what's that? It's a special loader right now it's a cube loader. All right, here they're using actually the cube texture. Now you could see the difference between the cube texture. For anyone that doesn't know that, it's gonna be just 6 HDR textures, but this is pretty weird. Probably the first time I ever see 6 HDR textures. This is like top, bottom, left, right, front, back stuff. All right. So here then, after I load the image, in my case, it's going to be just the usual texture. Well, yeah, I guess so. But then the only thing that Copilot struggles is the like brackets. Okay. So it actually creates a texture for me, like PMRAM from equirectangular texture. We're taking the texture. And then I think we also need to set the texture map in here, if I remember it right. So the end map is going to be PMRAM from a rectangular texture, but I'm not sure I need to texture. Doesn't it return the texture already? I also don't need this. And I don't need this. So I'm going to load the texture. When the texture is loaded, I'm going to convert that one to the environment map. All right. So what's going to be next? Let's see what's it returning to me. How does this even run? What's running here? Okay, the alert is running. Why doesn't it output anything then? Okay, it has, okay, it's render target, so we do need to take the texture out of this. And then this is gonna be the texture probably, right? Yeah, it's now a texture. I don't know what you guys are writing here, but you better use English. I think you're spamming here, so I'm gonna put you in the timeout. I'm sorry. I'm not really sure what you're messaging in there. And something with the name Putin doesn't ring a bell to me. Okay. Inf map. Okay, we have a texture, and then actually learned another way to use this texture for the environment map. It is usually done at the like scene environment, but we could also set it to the material. Actually, I didn't really know that, but three.js mesh standard material. There's actually an env map property, so you could set the env map directly to the material of your mesh. I didn't know that, because it means that you could use different env maps for different objects on your scene. I don't know if this is a recent update or not, but yeah, it's kind of curious, because before that I only knew that you can set it to the directly to this scene, the whole scene. So I thought you would need to create different scenes to use this. All right, let's see what's gonna happen now. So instead of mesh standard material, mesh basic material, which I used here, I'm gonna move this whole GLTF. It's kind of a waterfall, but yeah. So this is gonna be like this env map. Now I have it. Great to see all of you guys, and thank you for this support. It really means a lot. This stream is kind of hard and stressful, I guess, because this is the first one in a while, and I'm not really used to do this kind of stuff for a while right now. Okay, so we have this thing. So first of all, I'm gonna create new material, new mesh standard material with some properties probably, and then this human material equals this material. Okay, now it's black again. Yeah, it's right there, but it's black again. Now I can set the environment map. Now we could see something, but it's really far from what it should be, right? So first of all, I think metal has gotta be 1. This value actually useful when you're using the env maps. This value actually like correlates with the stuff we just seen. Where is that VMRAM generator? With the stuff we've seen here, because it actually, like, depending on the roughness that you're using, there's going to be the minimum texture size or the maximum texture size, as you wish. So let's see what we're going to see now. Okay, why am I Chrome stuck? Right, so it's starting to look better. And just so we remember again, this texture is being wrapped on a sphere, right? Like it's an equirectangular wrapping. So this means on the center of the texture, we actually see, well, something is on the center of the texture. But then on the edges, it's black, as well as on the top and bottom. But meaning on the left and right, it's black. Right now, what we see on this model, we see that it's being lighted from the right side, right? Well, if I rotate it, it changes, but you could see that the left side is kind of black on this model, right? Not black, it doesn't have lighting. So it is a black part of this spherical wrapped texture. And this means that if I change, this is a really important bit for this model, because you could see that when we look at this beautiful model, it actually black like on the inside. It's only on the edges that you see this beautiful texture, or like kind of on the edges. In the center, it's kind of black. Happy to see you guys. Happy to see you. Hello to Portugal as well. Right, so this means, well, I think there are a number of ways to go around this, but the easiest way at this case, I'm looking from the Z2 position. So if I just look from the left side, meaning I'm going to change the camera to this. Okay, not this, but the X. The X is the first. Right, and then maybe minus. Right, so now we could see like the same kind of look. So the color wraps on the edges. It's not on the center anymore. And if I do the rotation now to the model, so if we're just going to check. It's going to be white. Yeah, maybe too slow. You could see when we rotate the model, this effect is gonna stay, right? You can see the model is black right now. Whenever we look straight at the surface, straight at the S at this moment, it's just black. I mean, maybe centering exactly this kind of model wasn't such a good idea. I mean, geometrically centering it. But, you know, this is the geometric center of the human anyway. There's nothing wrong with that. This is the center of mass of 99% of the humans. Okay, anyway, so right now it doesn't look that cool, right? It's kind of, but not right. So let's see what we can do else. And this is really about the real subtle touches here, because, you know, like physically it's the same. It's just the color palette and the kind of the brightness, the luminance, something is wrong about it. And this is what you call a tone mapping. So three.js has a lot of tone mapping stuff inside. So the renderer actually have the tone mapping, like the constant, and then the tone mapping exposure. And all of those things are actually like curves that I should say distort the color, right? So they're not producing it as a linear or it was like simple gamma correction, but with something complicated. And I think I've saved some bookmark just so you see what for example one of them. So one of the tone mapping examples, we could go here, render constants, and these are the tone mapping constants that we have available in the three.js. So one of them, kind of, I believe, most popular of the from the default one, like the second popular from the default one, is actually, it is done with the shaders, but we're gonna get there. And yeah, so this one is used here, and just so you know, it's this kind of curve. So it almost looks like a smooth step or something, and this is just a simple mathematical transformation for the colors. Like we have the color input, we have some magic numbers, we have some super magic formula, and we produce the color. Well, but this is what the color grading, I guess, does, and it just makes everything a little bit more beautiful. So we can do it here. Okay, this is actually really helpful, and then it helps with the exposure. But let's also create settings, and then here, exposure. And well, yeah, I didn't want to do like this, but this is actually seems right. But I'm just going to directly change the exposure. So tone map and exposure is going to be just equal this settings exposure. Let's see what's going to happen. So right now, nothing really changed, and the default exposure, I think, is going to be, let's make it 2. All right, and here between 1 and 0 and 3. And you could see that this whole scene is actually, it actually felt like overexposed. I mean, we don't really have black pixels except the background, right? Everything here is, we don't have any blacks here. And this means we could just like underexpose it a bit, change the exposition, and we actually getting the same kind of look. And depending on the the exposure and on the latest effect that we're going to apply right now, it actually does the job. So we just need to underexpose it a little bit and we're going to get this effect. But there's more to that, of course. So then the next thing, this this lighting actually dynamic here. It doesn't, it's not static like right now what we see. So to do this, I'm gonna rotate this image, but there's no simple way to do that because it's already like baked in with the PMRAM generator. So to rotate it, it's actually easier to rotate the normals of the mesh than the object itself, right? I also wonder, does it change this map in here? Anything like this? Yeah, this is what we need to do. Oh, interesting. Why would it change so much? Maybe I don't really need it because I was... Well, this is the other kind of effect. I guess we don't need it because it does the opposite of what we need. It's not lighting, it does a reflection. Okay. Anyway, and then, yeah, it's probably something going to be close to 0. Right. So next thing to do is rotate this. Rotating normals. Right. To do this, we will need to override the default material here. And this is what we're going to do. So we have the this M, which is the perfect name, perfectly descriptional name for the material that I've been able to come up with. And then, how do you do that? This is just on before compile. Okay, so on before compile, it's got to be a function probably. Yeah, like this. And then in the end, data. We usually call this just the material. We're going to save the material into the shader probably. Yeah. Right. And then we're going to have access to this one because everything we do here, it's not going to be accessible like anywhere else. It's just going to be changing. So, well, yeah, this is what I need to do. The U time, I'm going to add the uniform to my shader because I obviously need to change something with the time. Then I'm going to replace a couple of things here. So first of all, I need to set my uniforms and for the fragment shader. So it's going to be shader fragment shader equals something plus shader fragment shader. And here I'm just gonna, yeah, uniform utime. So now I should probably have access to uniforms in my updated material. This is still mesh standard material, but I already have some access to here. Next thing I'm gonna do, oh, this is the actions we are doing here. They're not complicated, like in terms of number of lines, but they are complicated in terms of keeping things like in your head because don't mess everything up. There's a lot of stuff you can mess up here. Yeah, the first idea actually was to use the matcap, but it doesn't produce such a smooth lighting and it's not as beautiful. But there are probably some other ways because basically we are just faking some lighting with some random JPEG image. This is what we do. Right. So then I also want to put JLSL state stuff. So I'm gonna just put those formulas in here for me. This is just GLSL matrices rotation, basically just mathematical rotation of stuff. Just gonna format everything. Okay. So now we have the uniform time there. I would actually check if I have it. If this user data shader, gonna be if. Because on before compile doesn't happen at once, it takes some time. Well, I'm gonna at least this user data shader. Let's just see what's gonna be inside of this thing. Okay, doesn't quite work. This user data. Let's check if it has any user data at all. Okay. Still nothing to see. What's wrong here? If this okay, this one. So I have a shader. This is actually the copy of the material, but then here inside the uniforms, among all the default uniforms for the mesh standard material, I have to have the U time. Yeah, this is my custom U time here. So this works. And this is going to be like kind of a record number of properties referenced in one line, but yeah, let's go. We can do it even longer. So it's going to be this human user data shader uniforms utime value equals this time. That's 1, 2, 3, 4, 5, 6, just 7 actually, not that much. But I hope I did it right. So it's a shader uniforms. Shader. Is it double shader? Because I'm outputting its user data shader, and uniforms. Right? Am I doing it right? Yeah, it's uniforms and then utime. Yeah, it should be right. Okay. Should be right now. This is always a complicated step on. I really wish three.js would do something about it. It's like a pretty complicated step to override the default materials here. Yeah, faking Latin. The random images. That's true. That's so true. Okay, then let's go into the three.js repo because we need to see how they do it. Oh, I'm afraid I might not be able to fit everything in 1 hour, but let's see. So it's going to source, renderers, and then shaders. And then we need both shader chunk and the other stuff. So mesh physical is basically the same as the mesh standard material in most of the cases. And here are just the snippets of the code. So what we need to update here. The one that I need to update is about the image-based lighting. So it's going to be in the fragment shader. And how do they call it? Something cube UV reflection fragment. Just let me remind myself which one was that. I think it's this one in map physical parse fragment. But basically, when you have to look into every one of them to find out that. So this is the default code for the three.js. What I'm gonna do now, I'm gonna replace basically this line with my custom code, which for the moment is gonna be the default code. So this is the default three.js shader part for this one. Right, looks scary, right? But this is again image-based lighting, as you could see. Like IBL is short for this. It's kind of important to know those shortcuts because you can recognize which parts of the code are responsible for which. So the important part here is actually IBL, which is image-based lighting, which is we are using here. So here we are using we're not using the irradiance, obviously, we're using the radiance. And here we have the reflect vector. And we actually have a comments like reflection with a normal is more accurate than keeps reflection gathering. Okay. So here somewhere I would like to update my normal. And so I think the most sane way to do this, I mean, we probably could update the default normal as well, but we're applying a couple of transformation to this. So I think the basic way to do this is right here. So the reflect vec is the part that is used for the sampling. So basically, we are sampling this JPEG texture wrapped on a sphere, depending on the reflected vector. Meaning, we are looking at the object, the ray is reflected to some surface, and we see that color, the pixel color here. Oh, actually, it's the other way around because light comes to the object and reflects to our eyes, but that doesn't really matter which way it's going. So here I would like to rotate this. So reflect back is going to be rotated. Okay, it actually helps. So probably we will need to rotate on the which axis, because we're looking from the x axis. We're going to rotate around the x-axis as well. So this is y, but let's just see whether it works at all. It doesn't for some reason. Yeah, let's create here an error just to see if it's correct. Yeah, we are updating the shader. We're not rotating it though for some reason. Maybe we have some other JavaScript, or we still have some other JavaScript error here. So human user data. Oh, it's obviously not human user data. It's human material. Oh, now I'm going for the record. It's like 1, 2, 3, 4, 5, 6, 7, 8. Now it's 8. Not bad, right? What's your maximum here? Okay, now at least it's rotating. But I actually want to disable rotation for a moment because I want this rotation to happen and it doesn't happen for some reason. Okay, so maybe I manually rotate it. Okay, it's actually happening. The rotation is happening, but the axis is wrong. You could see that the lighting, okay, maybe closer look. The lighting is actually going like around the object, but in the wrong direction. So we have to pick the correct axis here, and I think it's the x-axis. That's obvious because we are looking from the x-axis again. So right now we are getting there. Of course, it's much slower probably. And let's change the default tone mapping here so it looks closer to the effect we are trying to achieve. And let's move camera closer as well. So the steps are not that complicated, right? But you have to know what you're doing to get there. Like underexposed, overexposed scene. Actually, it's even less than that. It's like 0.8 on mapping. You have to understand how everything works, that you're actually able to expose or underexpose the stuff. The files from the start of the video, I made them available on the Patreon, but I also coded them live on the YouTube. I just decided to make it a bit more harder to everyone to get there, but you could probably also get them on the code drops, because every tutorial on the code drops is using the same template, or any of my courses or anywhere, and it's basically a very simple three.js template. Anyway, let's add 2 more touches here. So what I want to do here, so basically this is the lighting effect that they are using, but there's also some post-processing, and what I want to show you as well is how they are doing this a bit more blurred look and how they are doing this effect like here, which is a bit glitchy and looking so nice and slick. So first of all, we are using the bloom here, which makes colors a bit more brighter and everything a bit more nicer. And let's use the bloom. This I'm gonna need to copy some stuff in here. The Copilot actually helps me with the shader path. I'm going to need it later, so I'm going to still add it. Samples, GSM. All right, we got this. This post-processing effect is actually, I mean, it's quite interesting. It's not too complicated, but it's quite interesting to learn. So let's init the post-processing here. I think I would also need to add something from like these parts, probably. But a bit later. Well, if you're in Discord, just ask about that error. We usually figure that out pretty fast. Or just message me anywhere. I think it's gonna be quite easy to help you with that. Okay, so I need to implement the bloom here. This is the part about the post-processing. Let's use it to do everything with this. This bloom pass. This is gonna be I'm gonna move settings a bit higher then. Okay, this everywhere. So this probably should get me a bloom. The very important thing a lot of people forget, including me actually, those a lot of people is actually me, is setting the size of the composer render target to the correct one. And sometimes it's actually better to serve it as like half of the size to optimize the performance. But anyway, so we have the composer. Let me just check if everything is correct here. At least we shouldn't have any JavaScript. We shouldn't have any JavaScript error. Okay. Bloom pass, also this. Right, now it's perfect. It's not rendering yet because to render it, we will need to change to this. Okay, now it's getting better. Obviously, this is too much, but if we play with the settings, we could get like closer to this look. I think it's some those magic numbers, save them somewhere. What was that? Maybe this. Or actually, it's better to play with the settings here, so I could just do this. It's always the best way. This setting, basically can do this. And the same for the other three. Other two. And this is going to be bloom threshold. Okay, so does it work right now? Doesn't seem to work for some reason. Why is that? Should be working. Bloom pass threshold, strength, radius. Yeah, it's just okay, I think it's working now, but we just have to figure out like, yeah, where the parameters are changing. So this is the never-ending process. And I believe like in every project, you have to do this and then just send it to the designers and then we'll work with this one. This is how you do it. And background is actually not lighted yet for me because why should be, maybe it's too black. Now it's too bright. I believe there's probably some object on the original scene that they put on the background. Yeah, right now you could see that we are lighting the like neighbor. Like this is also with the bloom with the lighting. So it's getting closer. Right, now let's bring back the rotation of the mesh. And let's create the final thing. What was the rotation of the mesh here? Right, but what was the parameter again that made it a little more beautiful and brighter? Let's make the threshold really small, like 0.5. 0.5. And then just the maximum strength. Let's go for the maximum. All right. Shouldn't do this in the production, but yeah. Yeah, it does create those color bending. I believe in the original website of the Midwam, they actually used the custom bloom path with more blurring render targets to avoid this thing. But in the end, I think if you are like that advanced that you care about the bending and well, usually the bending actually solved with the noise put over the website. But then again, if you're that advanced, I think it's better to just copy the bloom path and start to play with it yourself, like start to play with the parameters inside of it. Because there are some like baked in hard-coded values about the blur, which might not be perfect for your exact scene, but you can then copy paste it and play with it. Okay, so now that let's create this amazing like glitchy look. For this, I'm gonna copy the other post-processing from the three.js. Three.js examples, let's go there. Any will do actually, but this one, I think I've used it in previous streams as well, because we already have here something. Let's use this dot screen shader. I think in the original it's called holographic effect. Holo effect JS. And then let's change all the names in the same way. And now let's add this effect to our code. So we have the holo effect here. Hey, nice to see you, Jennifer. Okay. I wanted to add this effect, so I'm gonna holo effect from holo effect. And then just let's see how they add this effect. The dot screen shader. So they invoke it and then just composer at pass. You see, I don't really remember all this stuff. I mean, roughly. Remember it roughly. So this is going to be holo effect for us, and this. Holo effect. We don't really have this. All right, we have to see something now. We don't see anything yet because composer is not defined, of course. Still don't see anything because at pass. Oh yeah, I just invoked composer right here. And yeah, so probably should add it here. Okay, now we actually have a pretty cool effect on itself because we render our model with a bloom and then we apply the dot screen shader, which is actually shows you the amount of possibilities you have with the three.js and the post-processing. You could probably do anything. And for this might look like a particle animation to someone, right? But this is actually post-processing in 3D shape. Anyway, this is probably similar way which are all the ASCII renderers are done in three.js as well. Anyway, I don't really need this. I need to go deeper than that. Right? The side effects of doing something beautiful sometimes are even more beautiful. But we are on the final. 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 Oh, final animation. Okay, so here we're just sampling the original rendered 3D model. And if I just output this color, I'm gonna get the original one, right? But then we could play with this one. Now we could play with this one. There are a number of ways. If you look closer to this animation, you could actually see that there are some lines in here. You could see, I don't know how you call it, screen. There's a name for this effect also. But anyway, there are just lines like on a TV or something like that. There's also a duplicated, kind of a duplicated shape in here, which is moving. Like we have the original shape, but then we have like another shadow of the shape here, which is moving. So first of all, I'm gonna require the GLSL noise. Actually, any will do, but I said any will do, and now I'm spending a minute looking for the one that I want. Well, this is life. Anyway, I think probably any will do, but for some reason... Oh, this one is too big. Maybe I should take something smaller. Okay, this one. This is the one. But then again, any will do. I don't need this pattern anymore. I don't need this. I'm gonna copy the noise. Just so we are sure the noise is working. Where's the start of this noise even? It's vector 3 for this noise. Yeah, right, scan lines. Thank you. This is the word I was looking for. Right. So just to test that, and then, well, yeah, probably this. And here. Yeah, so we have the noise here. We also, I want, obviously, the time here. U time, and I have to declare it somewhere. So this is gonna be my holo effect uniforms, right? So inside here is this holo effect. Yeah, right, you see? The Copilot magic. Right. I think I probably need to, maybe not. Should be fine. Okay, this holo effect uniform utime value equals something, and then I could use this utime here just to check. Right, working fine. We got the noise. So the next step, I need to create those scan lines. How do you do that? There was actually a pretty interesting way, the way that they created it. So first of all, to do the duplicate, like the shadow of the texture, we need to sample the texture again. And for this, we need another set of UVs. Just gonna create another UV. Then I'm gonna like do something with this UV, distort it, and then I'm gonna sample it, and then this is gonna create me a shadow. New open source parallel noise caused Octavia noise. Okay, gotta use it then. I'm already an hour in the stream. I'm not gonna use it this time, but maybe the next time. But I think we are close. We're close. So first of all, I'm gonna sample the direction, and I want the direction to be randomly like either -1 or 1. And the way that they did this is actually pretty interesting. So they're sampling the UVs. So the UV, in this case, the UV is basically the screen coordinates. Because this is a post-processing, those UVs are just the screen coordinates. So if I multiply the UV here with the screen height, for example, and let's say it's 1000, it's roughly 1000 pixels height of my screen right now. This is going to be the actual value, the amount of pixels on my screen. So now I want to iterate, because those scan lines, they are like 1-2 pixels height. That's why I need to go to the pixel metrics here to get the exact scan lines of pixel perfect size, right? Then to iterate every 2 pixels, I'm going to take the mode of this. So the mode of this is going to be something between 0 and 4 always. And then depending on like whether this less or bigger than 2, for example, which basically is just like the first half and the second half, I'm going to just return -1 or 1. That's probably, usually I achieve this with the sine curve and then just a step function. And there are a bunch of other ways to achieve that, but this is the first time I've seen this kind of weird way to do this. But anyway, now this is direction is a float one, and I can, everything all right here. Something is wrong. Only defined for scalars. Where did I make a mistake here? So there's a direction. How is that not a scalar? Or should I like do this? Okay, wrong apparent types. No apparent exists left hand. Two-dimensional and right. Okay, yeah. Of course. It's a two-dimensional thing. Obviously. So I need to iterate on the vertical axis. That's why, hence the Y. Now we have the scan lines. Now I could actually add the time here. Last time it's gonna be way fast. So now we created a simple scan line shader. I don't know which speed should be here. It's probably gotta be something big, but we're gonna, okay. Let's make it 0.5 for a moment. Then let's see what's going to happen next. So right now it's either -1 or 1. And now we can sample our, like, we can update our texture, the direction, which way we're going to multiply it. So this again have to be something with the pixels, because I want my mesh to be distorted with like 10, 15 pixels. Yeah, the stream is always saved. All right, so this is 100. So I have to multiply direction with something pixels. And let's that be like 12 divided by 1000. So I'm assuming that my screen is 1000 by 1000 pixels. In the perfect world, this has got to be the width and the height of the screen. In this case, this is the width and this is the height of the screen. Ah, come on. I might as well just do that. So inner width. So this is gonna be hue size. So now we're gonna be talking real pixels here. Hue size, what's that? Y. And here, hue size X. Okay, I have some glitching. So right now I'm outputting the direction here. Am I doing it right? Window inner width, window inner height. Gotta be right? I'm just afraid I might have made a stupid JavaScript mistake here. Okay. Yeah, so something wrong with the hue size Y here. For God's sake, why? Hue size, window inner height. Gotta be right. But maybe it's because of the retina, because I have to account for the retina as well. So like, okay, doesn't really matter. In the perfect world, you would measure the screen size and account for the retina and the stuff, the pixel density, I mean. Okay, so we have this stuff, and now I can sample my mesh again. So I can create the hologram color. RGB, and then I can output it. And you could see we created a pretty cool effect in here. But that's not all. First of all, we need to move this stuff. So I'm going to create the here. I'm going to do something like 4 plus 8 multiplied with noise, how do you call it, line offset. Line offset is going to be equal, yeah, it's going to be noise. But this noise, I think I only need the float value here, so I don't really need the VUV here. So it's going to be like 0, 10, and then the U time. So this is going to be changing between -1 and 1. And this means here, maybe like this. So it goes between 4 and 12 in this case, 4 and 12 pixels in this case. Okay, something is wrong here. 166, line of set. Yeah, you can see it's moving now. So we're getting this kind of a look, but we lost the original shape in here. So we need to combine both of them right now. We're going to do it like this. We're going to have a combined color, which is going to be the color RGB plus hologram. But the hologram is going to be too strong now. It's going to be hard to see the original shape. So I'm just going to multiply it with something small. Or even, okay, I don't really preview the combined color right now. Yeah, now it's pretty weak, but you could see the shadow of the shape right now. We're almost there. It's just a small thing left. See, pretty cool look we are achieving with just a simple, you know, really simple math here. You could also actually oscillate this parameter, I believe. So instead of using here, I'm going to use the holo intensity, okay. And then the float holo intensity is going to be, again, some other seed, that same stuff. And then it's going to be like T0 plus 0.2 or 0.1. Well, it depends on the intensity that we want to create. It's going to get brighter or dimmer. It's going to dim or bright. See, it's like oscillating a little bit. And depending on the effect, we might change that, of course. You see it here. Sometimes it just gets a little bit brighter, right? That's pretty cool already. And then what else? What else left to do? A pretty nice mathematical thing left to do, which is called the luminance. So we should put this into the background. I think the background, what was the background was? And it's a pretty curious function that they're using. So the background is 065 1. So this is RGB, something bluish here. And let's just see. Yeah, something like this. So what I want to make this whole scene bluish, right? Because right now I still have the colors in there. Still have in combined color, still have this, all the beautiful rotated environment map here. So what's left to do is the luminance, and this is actually pretty interesting. Like, how do you go from something colorful to something grayscale? It's just a random link which shows you this. Might be better ones, but just bear with me. So the easiest way is to just sum up the RGB values and get the average. But this is actually not the best way to go around the colors to create something colorful, create a black and white image. There are actually a luminance formula, and I believe there are a couple of luminosity formulas, which is just the way to go from the RGB to one value, black and white. And the Photoshop and all the editors, they're not using the average, which is, well, still fine in some cases, but usually this formula is used. So each of the color channels gets its own weight. Like the green one is usually gets the more weight than the other ones. This is exactly what we need to do. So we need to run the luminosity formula here. And what's curious about this specific case, the guys at the Immersive Garden actually used the formula that used not just the luminosity of the image, but the relative luminosity to the background, because this is the background now, and this is the combined color, and they wanted to put the combined color onto the background. And they used like the difference in luminosity between the background and this combined color, which is pretty cool. And let's do this, I guess. What's left to do? I think we also need to dim a little bit the background because it's too bright, and in the original you see it's bluish, but it's pretty dark in there. So let's see what's going to happen if we multiply color. Yeah, it's I think it's exactly the color. Maybe some post-processing distorts it a bit. So we're almost there. The luminosity. How do you apply the luminosity? It's actually pretty easy. So we create the vec3, the luma, I don't know. Okay, it actually creates it for me. I believe it's one of the formulas to use it, but it's not too important which one you're going to use it. Usually the green one is still the most valuable one, the most weighted one in here. And then, yeah, you know, people did this so many times in GLSL that the Copilot knows already what I want to do. So usually it's a dot product. And why it's a dot product? Because basically we multiplying the red channel from combined color with the luminance red, which is this coefficient, and then same for all of them. But then we can have the same luminance value for the background. I'm actually curious, like, why the guys used this formula. Maybe it's beneficial in some other cases. Lum front, lum back. So we have the now the luminance for the front, and for the back we can actually output the front one to see how it's looking. Pretty cool. I mean, it's looking even better in the black and white with the scan lines. Maybe it's too much, but it's beautiful. And then they used the actually difference. So they used the difference between those. It's like a lum front, which is probably brighter. And the final color, the vec3 final color, is going to be the background. Well, that's pretty much it, but d multiplied just d. So the difference. So this is the difference in luminance between the front and the background. And we are adding this difference to the background. I'm not sure about this formula yet, but let's see. And now we get this look. So we put it on the background. And well, I mean, it just looks nice. It's probably like amplifying the original background color, and it takes this bluish neon light background color from that. And we are creating this thing. And this is basically it. This is the effect that we are looking in here. I mean, the strength could be a little bigger, and we can play a little with the coefficients here, which are follow intensity. I think it's gotta be something bigger or even bigger, like more intense animation, maybe. And we can also do this, the final touch. So we can go from the original scene to this scene. So by default, the progress is gonna be 0. Gonna have the progress here. Gonna have the progress here, and in the end, instead of outputting this, I'm gonna you know, like in those old PSD file memes, the final color is gonna be and Copilot actually trusts me. This is the final color, but it's not. Well, yeah, it's actually right. Actually right. And then I'm gonna put the final color. And the last bit, because the progress is 0, I need a way to change that. Progress is 0 here, and then this is going to be the hollow effect. Uniforms progress value equals this setting progress. Gotta be it, right? Whoa! Oh, this is actually interesting, right? Because I made a mistake, and the progress goes not just to 1, but it goes way up to the 3. It actually creates an interesting effect on itself. It's like an infinite amount of glitchiness, scanlining effects in here, and somehow the green pops out in here. Like, where would the green come? Oh, I know where the green is coming from. Because the parts of the mesh have different color, like we have the blue and the yellowish, probably one of those colors produces the green. But I mean, in the perfect world, it just goes to 1. In the normal world, I mean, not the perfect one. And you could just animate between those two states. Like no scan lines, just the perfect thing, and then go into scan lines with the glitchiness effect. And that's how you make parts of the midwam.com website. Well, it's a bit past the hour, but I hope you like it. I really love the effect of the original website, and of course you have to play with the settings to achieve the exact same. And I will tell you this, they changed those settings a lot during the animation. So in some parts of the animation, they just changed the tone mapping because it looks better like from the distance and so forth. So it's a constant play with the settings. Like right now it looks like something golden, right? Something magical golden. Yeah, so this is it. Hope you learned a lot of stuff in here today, because even though we didn't code maybe too much, but there's a lot of like basic foundational stuff with the color grading, with working with colors and stuff that you should learn in the graphics to know that you like what you're doing actually, and whether you will arrive in the effect in the end. But in the end, you see, it's pretty simple, right? I mean, there are some complicated steps, but it's not so much code. Just replaced part of the code. Probably this was the most code savvy part of the stuff. Right. Whew. It's been some stream. Yeah. I promised in the end to show you some stuff that I've been drawing lately, because I lately was experimenting with the brush textures. Actually, the curious thing, like 5 years ago, my webgl journey started with these brushes. So it's not so many questions I asked on Stack Overflow over the years, but yeah, I was trying like almost 5 years ago. I've been trying to achieve this. Come on, it's gotta be a video. Oh, I even have a demo. Okay, yeah. This is a glitchy demo that I was trying to achieve. Well, it's not perfect, far from perfect, have a lot of glitches, but lately from some of the other like websites and developers, I combined some techniques and I actually learned how to like draw these kind of brushes finally, and it looked so beautiful. Actually, 3 different brushes I used from one of the websites. You're gonna see in the next streams probably. I hope I will be able to tell a story about these brushes as well, because I just love watching them draw something. This is the face. I also made a lot of drawings with, yeah, I also tried to make a Japanese calligraphy here, but the moment I tried to do that, I learned that in the Japanese calligraphy and the Asian calligraphy and maybe Chinese calligraphy, this is, you have to account for the angle of the brush, like it becomes thicker and thinner, so it's way more complicated than just simply drawing stuff. Yeah, but the output, some of the outputs I just love. It's like a painting I'm ready to put on my wall actually, because I love this kind of abstract paintings. And these color palettes, yeah. But I also worked with some three.js themes. Maybe in the next streams I'll show you how to do, not this, something this. I tried with the year a lot. Okay. And this, yeah, I tried also to paint, well, I'm sorry if this is objectification, I'm just trying to paint something human-like. And this turned out to be pretty cool, like almost like a painting. Okay, not for the brushes, yeah. This is part that I like. Maybe in one of the next streams I'll show you how to do this as well. Yeah, pretty nice. It's actually a three.js scene with the shadows, as you can see, but there's also a two-dimensional part in it because you need to pack. It's not just random lines because they would intersect otherwise. So you have to pack them so they don't intersect and they cover the whole scene. I'm using this woman shape or contour because it has a lot of nice normal maps. That's why I'm using it. Yeah. So I've been trying to draw the Libre again, also with three.js. So this is what I've been working on, but lately we didn't really have a lot of power here in Kiev because the war is going on. And again, this stream is only possible because of the amazing work of our army, which I'm trying to help, and I'm proud to be part of this country. So I'm going to read the chat and I'm going to end this stream. No, I didn't sell it as an NFT because I'm not sure if this is a good idea. So maybe sharing the knowledge is better for me. Yay, great to see you all, guys. It was great to see all of you. Sorry, it's a bit over the hour, but hope you like that. Contact page graphics are amazing too. I actually didn't see that one. Maybe. Oh yeah, oh yeah. But you could see it on the main page as well. This could be another stream because to achieve this effect, I mean, it's bloom, but then there's also the RGB, the aberration shader. How do you call it? The aberration. Yeah, there's an aberration because there's an RGB shift on the corner. It's pretty cool. Pretty cool. Yay! Slava Ukraini! Slava Ukraini! Thank you guys for being with me. Hope you like that. I'm gonna end this stream so it doesn't go over the Hiva Palva. Hiva Humenta! My friends, because I don't remember what is Hiva Palva. I only remember the Humenta and the Ilta and the Öta part. Thank you guys. Hope you'll be having a good day. Stay safe and Slava Ukraini!